everyone, welcome back for another deep dive. We always try to tackle some of the biggest names and most challenging ideas in philosophy, and, well, today is no exception.
Yeah, we're going deep into the world of Gottfried Wilhelm Leibniz.
I mean, this is a thinker who is really trying to wrestle with some pretty fundamental questions about the nature of reality,
Yeah.
about the nature of knowledge, questions that are still very much alive for us today.
For sure. And for you as a philosopher, I think his ideas about these things really provide a kind of foundational perspective for
Yeah.
so much of what came after.
Absolutely. And, Leibniz lived a pretty long life from 1646 to 1716. And in that time, he did an incredible amount. I mean, you always hear him described as the last universal genius. And when you look at what he accomplished, it's hard to disagree with that.
Yeah, he really did it all. He made significant contributions to just about every field you can think of. Metaphysics, epistemology, logic, philosophy of religion, math, physics, geology, and he even dipped his toes into law and history. It's pretty mind-blowing.
It really is. And it's amazing to think about, how much influence he's had on subsequent thinkers. I mean, folks like Diderot and even, Frege, much later on, were just awestruck by him.
Yeah, it's a reminder of how much one person can do, but also, I think, of how deep those philosophical questions really go.
Definitely. And that's what we're here for today, to really dive into some of Leibniz's core philosophical concepts. And we'll be relying on the Stanford Encyclopedia of Philosophy entry on Leibniz for this one.
Great resource.
It really is. Although, with Leibniz, even finding your way around his work can be a challenge. I mean, he didn't leave behind one single, magnum opus that lays out all of his thoughts in a systematic way.
That's true. Unlike some of his contemporaries, you don't have like one big book that you can just sort of go to for all of his ideas.
Right. And so instead, we're left with this huge body of work, like essays and articles and all of these unpublished manuscripts, and then tons of letters. I mean, he was a prolific writer, but that also makes it tough to figure out exactly what he thought at any given time.
It's like a puzzle. We're kind of piecing together his philosophy from all these fragments. And his thinking evolved over time, so you have to be really careful about the chronology.
Yeah. And for anyone trying to really understand him, it's important to remember the context he was working in, too. I mean, on the one hand, he was really grounded in that tradition of scholasticism and Renaissance humanism.
That's right. He was clearly influenced by Aristotle and Plato and the Christian thought of his time, but he was also engaging with those new and radical ideas coming out of, the modern period.
Right, like from Descartes and Hobbes and Spinoza, all of whom were challenging some pretty deeply held assumptions about the world. So you can kind of see Leibniz's work as this really ambitious attempt to sort of bring together those ancient and modern perspectives.
Yeah, like he's trying to find some kind of synthesis that can account for what he sees as, the best insights from both sides. And, to do that, he needs to set out some pretty fundamental principles.
Yeah, and that's where we see, these two really famous principles that are kind of like the cornerstones of his whole system. And I think we should start there.
Yeah, for sure. He himself calls these his, two great principles. And the first one is the principle of contradiction, PC.
Right, and this one seems pretty intuitive on the surface.
Yeah, it basically says that a proposition can't be true and false at the same time. Or, to put it another way, A is A, and it cannot be not A.
I mean, that makes sense, right? If you're going to have any kind of coherent thought, you have to start there. You have to be able to rely on that kind of consistency. But then there's that second principle, and this one seems a bit more complicated.
Yeah, this is the principle of sufficient reason, or PSR.
Right, and what's that all about?
Well, he puts it in Latin, of course. Nihil est sine ratione.
Okay, for those of us not fluent in Latin.
Basically, it means that nothing exists or occurs without a reason.
So everything has an explanation.
Exactly. And Leibniz thought that this principle was really powerful. He saw it as underlying not just metaphysics, but also physics and even morality.
So for anyone following along, let me try an example. Like, if I see a particular tree standing in a particular spot in the forest, according to PSR, there has to be a reason why that tree is in that spot and not somewhere else.
Yeah, and not just that. There has to be a reason why it's that kind of tree and why it has that particular shape and even why it's grown in that way over time.
So, like, even something seemingly random, like the way a tree grows, has a reason behind it.
Absolutely. Of course, Leibniz also recognized that, we don't always know what those reasons are. We're finite beings. We can't grasp everything. But he thought the principle itself was sound. that there must be a reason for everything, even if it's hidden from us.
So it's not about us knowing the reason, it's about the certainty that there is one.
Exactly. And those two principles, PC and PSR, they really provide a kind of framework for everything else in his philosophy.
Yeah, they're kind of like the ground floor. But then he has all of these other principles that kind of build on those two, right?
He does. A few others that are really important for understanding his system are the principle of the best, the predicate and notion principle, the principle of the identity of indiscernibles, and the principle of continuity.
All right, let's unpack some of those. What about that predicate and notion principle? It's kind of a mouthful. What's that one all about?
So this principle, or piana, it's a really key part of his philosophy. It basically says that in every true affirmative proposition, the concept of the predicate is somehow contained within the concept of the subject.
Okay, help me out here. What does that actually mean?
So think of it like this. If you say something like, the triangle has three sides, the idea of having three sides is already part of what you mean by triangle. It's kind of built into the concept itself.
Right, that makes sense. It's like the definition of a triangle.
Yeah.
But is Leibniz saying that this is true for every single truth statement, not just definitions?
Yeah, he thought it applied to all of them, whether it's a necessary truth, like in math, or a contingent truth about the world, whether it's a statement about a specific thing or about something general. He thought the predicate was always, in some way, contained within the subject.
And he actually traces this idea back to Aristotle.
Yeah, he sees it as kind of implicit in Aristotle's work, and he also finds some hints of it in the work of Arnauld and Nicole, but he really develops it into this central principle for his own philosophy.
Okay. Now, another one that I always find fascinating is that principle of the identity of indiscernibles. What can you tell us about that one?
All right, so PII, this one's a bit tricky, but really important. Basically, it says that if two things have all of the same properties, then they are actually the same thing.
So if there's no difference between two things, they're identical.
Oh, exactly. But there's a really important caveat here.
Okay, what's that?
Leibniz specifically says that purely spatial or temporal properties don't count.
So like where something is in space or when it exists in time.
Exactly. He's saying that those kinds of properties aren't enough to make two things distinct.
Can you give me an example?
So imagine you have two atoms, right? And they're absolutely identical in every way. They have the same mass, the same charge, the same spin, everything. The only difference is that they're located in different places in space.
Okay.
Leibniz would say that those two atoms are actually the same atom. They're not two distinct things.
But that seems counterintuitive, right? I mean, they're in different places.
I know, but think about it this way. If those two atoms were truly distinct, then God, when he created the universe, would have had to choose to put one of them in one place and the other one in the other place.
Okay.
But if they are truly identical, there would be no reason to choose one over the other. And according to the principle of sufficient reason, there has to be a reason for everything.
Ah, right. It all comes back to PSR.
It does. So Leibniz is saying that if there's no intrinsic difference between two things, then they must be the same thing. And this principle has some really interesting implications for his views on things like atomism and Newtonian absolute space, which were big debates at the time.
Right. He's arguing against the idea that you can have all of these little bits of matter that are completely alike, just floating around in space.
Right, because for him, that kind of empty space is just, it's not a real thing. It's just a way of talking about the relations between things.
Okay, so you've got PC, PSR, PAN, PII. What about the last one? The principle of continuity.
Right, so this one says that nature never makes leaps. Leibniz gets this idea from mathematics, and he applies it to pretty much everything.
Okay, how so?
Well, he thinks that any change that happens, it happens gradually. It passes through an infinite number of intermediate stages.
So even something that seems like a sudden change.
Yeah, he'd say there's actually a hidden continuity there.
Yeah.
And this principle, it helps him to explain things like, well, how do we go from having these tiny little perceptions to having big, obvious perceptions?
Right, because he has this idea that everything is made up of these tiny little perceiving things, which he calls monads.
Exactly. And the principle of continuity helps him to explain how you can get from that level of minute perceptions to the level of conscious experience.
Okay. And he also uses this principle to argue against the idea of absolute rest.
Right. He thinks that everything is always in motion in some way. And this is connected to his idea that there's this infinite hierarchy of monads where the differences between them are often a matter of degree rather than kind.
Okay, so that's a pretty good overview of those key principles, and I think it gives us a good foundation for understanding the rest of his philosophy. So let's shift gears a bit and talk about his metaphysics.
Sounds good.
And I think for anyone who's really interested in those big questions about the nature of reality, this is where Leibniz really shines. So what would you say, what was his fundamental view on what the world is really made of?
Well, for Leibniz, the central question of metaphysics was always about ontology. What is there? What are the most basic things that exist?
Right. And what was his answer to that?
His answer, in a nutshell, is that everything is ultimately made up of simple substances.
Simple substances. Okay, for those of us who haven't studied Leibniz before, can you break that down a bit?
Sure. So by simple, he means that these substances don't have any parts. They can't be broken down into anything smaller.
So they're like the ultimate building blocks of reality.
Exactly. And he also thought that these simple substances were active, that they had a kind of internal force or energy that was constantly driving them to change.
Okay, so that's what he means by simple, but what about substance? What does that word mean for him?
This is where things get really interesting. Leibniz had this really fascinating idea called the logical conception of substance.
Okay.
And this is where he brings in that predicate and notion principle that we talked about earlier.
So those principles are really starting to connect.
Yeah, they're all part of the same system.
Mm.
So according to Leibniz, every substance has something called a complete individual concept, or CIC.
A complete individual concept. What is that?
It's basically a concept that contains all of the predicates that are true of that substance. Everything that can be said about it, past, present, and future.
So for us trying to wrap our heads around this, like everything that is true about a thing is already contained within this concept.
Yeah, it's kind of like it's like a blueprint for the entire existence of that substance.
Right.
And this is where he famously uses the example of Alexander the Great.
Ah, yeah, that's a classic Leibniz example.
So, the CIC of Alexander the Great, it wouldn't just include the fact that he was, the king of Macedon and a student of Aristotle.
Hmm.
It would also include every single action he ever took,
Yeah.
every thought he ever had, every battle he ever won or lost, everything.
Wow.
And Leibniz thought that God, being omniscient, knows the CIC of everything that exists.
So God sees all of the, all of those details about Alexander the Great.
Yeah, and not just sees it, but understands it. He knows why Alexander the Great did the things he did, why he thought the things he thought. And he knows this because all of that is already contained within Alexander the Great's CIC.
So it's like God is reading the blueprint of Alexander the Great's whole existence.
That's a good way to put it. And this idea of the CIC, it has some pretty radical implications.
Like what?
Well, for one thing, it means that no two substances can be completely alike.
Because their CICs would have to be different.
Exactly. If two substances had exactly the same CIC, then they would be the same substance. There wouldn't be two distinct things. And this is connected to what Leibniz called the doctrine of marks and traces.
Okay, now that's a new one. What's that all about?
It's this idea that every substance somehow bears the mark of everything that has ever happened to it, and that it also leaves its mark on everything else that it interacts with.
So like every experience leaves a trace on a substance.
Yeah, something like that.
All right.
And Leibniz thought that if we were smart enough, we could actually read those traces and learn about the entire history of the universe just by looking at a single substance.
Whoa, that's a pretty wild idea.
It is, but it follows from his view that each substance is like a microcosm. It reflects the entire universe from its own particular perspective.
Right, it's like each substance contains the whole story of the universe.
Exactly. And this idea, it leads Leibniz to some pretty counterintuitive conclusions.
Like,
Well, for one thing, he thinks that substances can't be created or destroyed. They can only come into existence through creation by God, and they can only cease to exist through annihilation by God.
so no coming into being or passing away naturally.
Right. And he also thinks that substances are indivisible.
So you can't like split a substance in half.
No, he thinks that would be impossible.
Yeah.
Because if you could split a substance in half, then each half would have to have its own CIC. And that would mean that the original substance was actually two substances all along.
Okay, I see. So that ties back into that idea of the CIC as like a blueprint for the whole thing.
Exactly. And this also means that one substance can't be constructed out of other substances.
So it's not like you can't take a bunch of atoms and put them together and get a new substance.
Right. He thinks that substances are the most fundamental things. They can't be built out of anything else. And the number of substances in the universe always stays the same.
Okay, I think I'm starting to get a sense of how radical these ideas are.
They definitely challenge our common sense view of the world.
Mm.
And this leads to another really important consequence of Leibniz's metaphysics. He thinks that there's no genuine causal interaction between substances.
Wait, what? None at all.
None at all.
So, like, if I hit a billiard ball with a cue stick,
Yeah, Leibniz wouldn't say that the cue stick is causing the billiard ball to move,
but how?
because he thinks that all of the changes that happen to a substance are already contained within its own CIC. So the billiard ball, it was already going to move in that way even before the cue stick hit it.
So it's like everything is just playing out according to a predetermined script.
Kind of. He calls it pre-established harmony.
Pre-established harmony, right? That's one of his most famous ideas. Can you say a little more about that?
Yeah, so Leibniz thought that God created the universe in such a way that all of the substances in it would act in perfect harmony with each other, even though they don't actually interact.
Okay, I'm still trying to picture that.
It's like, imagine two clocks, and they are perfectly synchronized. They tell the exact same time, but they don't influence each other in any way.
Right.
Leibniz is saying that all the substances in the universe are like that. They're all perfectly synchronized with each other because God set them up that way at the beginning of time.
So it's like God is the ultimate clockmaker.
Exactly. And this pre-established harmony, it explains how things seem to interact with each other even though they don't.
Right. Like how my mind seems to be connected to my body.
Yeah, that was a big problem for philosophers at the time. They couldn't figure out how something that's immaterial, like the mind, could interact with something that's material, like the body.
Right. It's that classic mind-body problem.
Exactly. But Leibniz's solution is to say that they don't actually interact. They just appear to interact because they're perfectly synchronized.
Okay, so that's pre-established harmony. And it's all about, how God set up the universe to work in this incredibly precise and harmonious way.
Exactly. And this idea, it has a lot of implications for how Leibniz thinks about things like causation and free will. But we can get into those later.
Yeah, maybe we can do a whole deep dive just on pre-established harmony. But for now, let's keep going with his metaphysics.
Sound good.
So we've talked about simple substances, and we've talked about pre-established harmony, and both of those ideas, they seem to lead pretty naturally into Leibniz's idealism, which is another one of those ideas that, it can be a bit tough to wrap your head around at first.
For sure. Leibnizian idealism can be a bit of a mind bender.
It really can. So can you give us a crash course in Leibniz's idealism?
Yeah, so basically, Leibnizian idealism says that the only things that are truly real are minds.
Mm.
Or more specifically, they're these simple substances that we've been talking about. But he calls them monads.
Monads. Okay, so we're shifting from simple substances to monads. Are those two terms interchangeable?
Pretty much, yeah. He uses both terms to talk about the same thing. And he thinks that everything else that we experience, like physical objects and even space and time, these are all just appearances. They're not real in the same way that the monads are real.
So like when I look at this table, the table isn't really real.
Well, it's real in a sense. He calls it a phenomenon. But it's not real in the same way that, say, my mind is real. Because he thinks that the table is ultimately just a collection of perceptions. It's the way that my monad is perceiving the monads that make up the table.
Okay, so it's real in that it's a real perception.
Right. But it's not a substance in the same way that the monads are substances.
Okay. So then what are these monads? Like what are their qualities? How do they work?
Well, each monad is like a little universe unto itself. It's a simple, indivisible substance that has its own internal world of perceptions and what Leibniz calls appetitions.
Appetitions.
Yeah, it's basically a kind of striving or desire. Is what drives the monad to change its perceptions. And Leibniz thought that each monad is constantly changing its perceptions. It's like a little movie that's always playing inside the monad.
So each monad is kind of like experiencing its own little world.
Yeah, and it's experiencing the whole universe from its own unique point of view. But it's not actually interacting with the other monads.
Right, because of pre-established harmony.
Exactly. So all of the changes that happen to a monad, they're all internal to that monad. They're driven by its own appetitions and its own internal laws. And this is where that doctrine of marks and traces comes in. Because Leibniz thought that each monad, it bears the traces of everything that has ever happened to it and of everything that it will ever experience.
So it's like each monad has a kind of memory of the whole universe.
Yeah, you could say that. And Leibniz even thought that if we were smart enough, if we had God's infinite intellect, we could actually read those traces and learn the entire history of the universe just by looking at a single monad.
Wow. So each monad is like infinitely complex.
Yeah, they are. And Leibniz thought that there are an infinite number of them.
An infinite number of monads, each with its own, internal world of perceptions. That's a lot to take in.
It is. But it's a pretty amazing picture of reality when you think about it.
It is. And it also raises some pretty big questions about our own place in the universe. I mean, if everything is just perceptions, then what are we?
Well, Leibniz would say that we are souls, or more specifically, we are dominant monads.
Dominant monads.
Yeah, so he thought that there are different levels of monads, and some monads are more dominant than others. And human beings, we are souls. We are dominant monads that are associated with bodies.
So my body is not really me.
Not exactly. Your body it's a kind of collection of monads that are being controlled by your dominant monad, which is your soul.
Okay. So it's my soul that's really me.
Yeah, he thought that the soul was the seat of consciousness and thought and all of the things that make us human.
Okay. And he has all of those different terms for different kinds of souls, right?
Yeah, he talks about rational souls
Yeah.
and sensitive souls and even bare entelechies, which are like the most basic kind of monad.
Right. And all of these monads, they make up like this huge hierarchy.
Exactly. And at the very top of that hierarchy is God.
Of course.
God is the ultimate monad. He's the most perfect monad, and he's the source of all the other monads.
Okay, so God creates the monads, and then they all sort of unfold according to their own internal laws in perfect harmony with each other.
Yeah, that's the basic picture.
Okay, I think I'm starting to get it, but it's definitely a different way of looking at the world than what most of us are used to.
It is. But it's a very rich and complex metaphysics,
Mhm.
and it's one that has been really influential in the history of philosophy.
Yeah, I can see that. Okay, so we've talked about Leibniz's metaphysics. What about his epistemology?
All right, so Leibniz was also really interested in the nature of knowledge. And he had some really interesting ideas about, how we know things and what kinds of knowledge are possible.
Right, because that's a big part of philosophy too, right? Like, how do we know what we know?
Exactly. And Leibniz, he was actually a rationalist.
A rationalist, what does that mean?
It means that he thought that reason is the ultimate source of knowledge.
So not just our senses.
Right. He thought that our senses can give us information about the world, but that they can't give us true knowledge.
Okay. So how do we get true knowledge according to Leibniz?
Well, he thought that we have these things called innate ideas.
Innate ideas, that sounds familiar.
Yeah, it was a pretty common idea among rationalist philosophers.
Yeah.
And it's basically the idea that we're born with certain ideas already in our minds.
So it's not like we learn everything from scratch.
Right. Leibniz thought that there are some things that we just know intuitively. And he has this really famous example where he talks about, does the soul have windows?
Okay, I remember that one. What was that all about?
Well, he's basically arguing against the empiricist view that all of our knowledge comes from our senses. Because the empiricists thought that our minds are like blank slates at birth. And then our senses kind of paint the world onto those blank slates.
Right, that's the tabula rasa idea.
Exactly. But Leibniz, he thought that was ridiculous. He said, if our minds were really just blank slates, then how would we ever be able to make sense of our sensory experiences? We wouldn't have any way of organizing them or understanding them.
So he's saying that we need some kind of like pre-existing framework in our minds to make sense of what our senses are telling us.
Exactly. And that's what he meant by innate ideas.
Okay, so that's one way that he argues for innate ideas. What are some of his other arguments?
Well, he also thought that empiricism just couldn't explain certain kinds of knowledge that we have. Like, he's really interested in mathematics.
Right, he was a brilliant mathematician himself.
Yeah, and he thought that mathematical truths were necessary truths. They're true in all possible worlds. And he thought that our knowledge of those truths couldn't possibly come from experience.
So for someone who's not a mathematician, can you give an example of that kind of necessary truth?
Sure, like the statement 2 plus 2 equals 4. That's not something that we learn from experience. It's something that we just know intuitively. And Leibniz thought that the only way we could have that kind of knowledge is if we were born with it.
Okay. And what about those Petit's perceptions? How do those fit into his epistemology?
So Petit's perceptions, they are kind of like the opposite of innate ideas.
Okay, how so?
Well, innate ideas are these big general ideas that we're born with. But Petit's perceptions, they're these tiny little perceptions that we're not even aware of.
So we have these grand overarching principles and then all these tiny little experiences.
Exactly. Leibniz thought that we're constantly bombarded with these petite perceptions, but most of them are just too faint for us to notice. It's like the individual drops of water that make up a wave.
Okay.
We don't see the individual drops, we just see the wave.
So we're only aware of, like, the overall effect.
Right. And Leibniz thought that these petite perceptions, they play a really important role in our unconscious mental life. They would give us our sense of continuity and wholeness.
So even when we're not paying attention to something, we're still kind of perceiving it in a way.
Yeah, in a way, it's just that those perceptions are not conscious. And Leibniz thought that this was actually a good thing, because he thought that if we were conscious of all of our petite perceptions, we would be completely overwhelmed.
Right, we'd be like paralyzed by all the information.
Exactly. So it's kind of like our unconscious mind is doing all this work behind the scenes to make sense of the world and present us with a coherent picture of reality.
Okay, so we've got these big innate ideas and all these little petites perceptions, and somehow it all comes together to give us knowledge of the world.
Yeah, that's the basic idea.
Okay, but how do we actually get from perceptions to knowledge?
Well, Leibniz thought that we do that through reason.
Right, back to reason again.
Exactly. He thought that reason is what allows us to connect our perceptions together and to understand the relationships between them. And he thought that there are two basic kinds of truths that we can know: truths of reason and truths of fact.
Right, we talked about those a little bit before. Can you remind us what those are again?
Sure. So, truths of reason, they are truths that are necessary. They're true in all possible worlds. And we can know them through logic and analysis.
Like those mathematical truths we were talking about.
Exactly. And then there are truths of fact. And those are truths that are contingent. They're true in this world, but they could have been false.
So those are more.